Hello students, in this presentation we are going to study the properties of the DFT and some examples of the DFT. Of these properties of the DFT are applicable to the discrete time signals that have DFT, and the meaning of these DFT apply to any generic signal x of n for which x of k exists. That is, if you take the x of n, its transformation into the DFT, you will get the x of k, which is equal to summation n is equal to 0 to n minus 1 x of n into e raised to minus j2 pi k n by n. So the first property is the linearity property, where the a1 x1 of n plus a2 x2 of n, and if you take the DFT of this signal, a1 x1 of k plus a2 x2 of k, that is, if the two input signals are available, x1 of n and x2 of n periodic signal, and having the multiplied coefficients are the a1 a2, so the output will be a1 x1 of k plus a2 x2 of k. Periodicity: if your signal x of n is uh, added or repeated itself after the n interval for that is equal to x of n for all n, then your x of k or transformed signal x of k plus n is equal to x of k for all n. So if input signal is periodic, then the DFT signal should be the periodic. Time reversal: if x of n minus n is delayed version or the reverse signal, then its DFT is also reversed, that is x of n minus k. Duality: that is x of n, its DFT is the nx of minus kn. Circular convolution: if two input signals are convolved, then its DFT is multiplied, that is x1 of n convolved with the x2 of n, then its output DFT is multiplication of the both signals, that is x1 of k into x2 of k. Second, circular convolution: for x of n and y of n, that is a circular correlation, r of x y of n is r of x y l, its DFT will be r of x y of k, that is x of k into complex of y of k. Circular shift frequency: if x of n into e raised to 2 pi j l n divided by n, its DFT will become x of k plus l. If x of n into e raised to minus j2 pi j2 pi ln divided by n, its DFT will become x of k minus n. Circular time shift property: x of n minus l into n, that is equal to x of n minus l, its DFT will become x of k into e raised to minus j2 pi k l divided by n, or x of k into twiddle factor, where that is x of k into w of k l to the base n, where w is the twiddle factor. Circular symmetric properties: if the circular shift is, that is, the anti-clockwise direction, means positive direction, that is a delayed discrete time signal. Clockwise direction means negative direction, advanced discrete time signal. Time reversal, that is obtained by reversing the samples of discrete time signal about the zero axis or locating the x of n in clockwise direction. Multiplication, that is property, that is x1 of n into x2 of n. If input signal is multiplied, then its DFT is equal to convolved into 1 by n, that is 1 by into x1 of k convolution with the x2 of k. Complex conjugate property, that is complex of input signal x of n, so its DFT will become complex of DFT signal x of n minus k. Symmetry property: for the even sequence, x of k is equal to summation n minus n is equal to 0 to n minus 1 x of n cos of 2 pi kn by n, and for the odd sequence, x of k is equal to summation n is equal to 0 to n minus 1 x of n sin of 2 pi kn by n. Parseval's theorem: summation n is equal to 0 to n minus 1 x of n multiplied by y of complex y of n, then its DFT will become, that is equal to 1 by n summation k is equal to 0 to n minus 1 x of k into complex of y of k. So this is the proof of the linearity property. The DFT of linear combination of the two or more signals is in the sum of the linear combination of the DFT of individual signals. That is, we can prove that is A1 x1 of n plus A2 x2 of n. Its DFT will become A1 x1 of k plus A2 x2 of k. So use the DFT formula with the twiddle factor. X of k is equal to summation n is equal to 0 to n minus 1 x of n w of nk to the base n. That is k is equal to 0, 1 to up to n minus 1. Here x of n is equal to A1 x1 of n plus A2 x2 of n. Therefore x of k will become summation n is equal to 0 to n minus 1 a1 x1 of n plus b2 x2 of n into the twiddle factor. Multiply the twiddle factor into the bracket, so you will get the next term. So that is a1 summation of x1 of n into twiddle factor plus a2 summation x2 of n into the twiddle factor. So that is, this term is nothing but the x1 of k and this term is nothing but the x2 of k. So you will get the a1 x1 of k plus a2 x2 of k. So hence proof. So in this way you can prove all the properties. Here are some examples to compute the DFT. Suppose the input sequence is given x is equal to 1 0 minus 1 0. So you can use the formula summation x of k is equal to summation n is equal to 0 to n minus 1 xn e raised to minus j 2 pi kn. Okay, so here the n is equal to 4. So n is equal to 0 to n minus 1 means 3. So x of n is equal to 0 to n minus 1 is 3. X of n into e raised to minus j 2 pi by 4. So it becomes 2 2 getting 2 ones are 2 2 to the 4. So that is pi by 2. So e raised to uh, j pi by 2 means minus j. So therefore this terms becomes minus j raised to nk. So nk is index of e raised to minus j 2 pi kn by n. So here we get the term, reduced term minus j raised to nk. So put the values of the k. So for k is equal to 0, k is equal to 1, k is equal to 2, k is equal to 3. So you will get the 1 minus of minus j raised to 2k. So you can use the values of k for 0, 1 and 2. So you will get the output xk is equal to 0 to 0 2. So in this way you can solve the example. Let us take the example x is equal to j0 j1. So use again the formulas. Summation x of k is equal to summation n is equal to 0 to n minus 1 x of n e raised to minus j2 pi kn by n. So here n is equal to 4. So xk is equal to j plus j minus j raised to k 2k plus minus j raised to 3k for k is equal to 0 to 3. So you will get the x is equal to 1 plus 2j j minus 1 plus 2j minus j. Let us take the one more example. X is equal to 4 times 8. So here n is equal to 8. So twiddle factor e raised to minus j 2 pi by 8. That is e raised to minus j pi by 4. So use the formula, that is summation n is equal to 0 to n. X of n is 1 itself into twiddle factor raised to n minus k. So here 1 minus twiddle factor raised to 8k. So for the k is equal to 0 to n minus 1. So twiddle factor e raised to minus j 2 pi by n raised to n. So it is equal to 1. So therefore you will get the 8 into 4, 7 times 0. Next example, x of n is equal to cos of 0.25 pi n for n is equal to 0 to 7. So n is equal to here 8. So again the twiddle factor is e raised to minus j 2 pi by 4. Therefore expand the equation. X of k is equal to summation n is equal to 0 to n minus 1 x of n e raised to minus j 2 pi k n by n. So here the x of n is cos of 0.25. So expand these terms. So cos of, so you will get the 1 by 8, 1 by 2 summation n is equal to 0 to 7 e raised to j pi by 4 into k minus 1 into n plus summation n is equal to 0 to 7 e raised to j pi by 4 minus k minus 1 into n. So you will get the answer 0 4 4 times 0 4. Similarly, you can use this example 0.9 raised to n. So you will get this answer by using the equation x of k is equal to summation n is equal to 0 to n minus 1 x of n e raised to minus j 2 pi kn by n. So here n is equal to 8. So you can use first of all 0.5 raised to 8. So you can expand this equation and you can obtain the output. So use the same example for obtaining the DFT. X is equal to 1 j minus 1 j and h is equal to 0 1 minus 1 1. So here the output will become 4 times 1. Thank you.